Good day, ma'am. I am Matanghili Gakot from BSEE 2B. So, quiz number 3, Math 22, Engineering Data Analysis. For problem number 1, from a box containing 4 black balls and 2 green balls, 3 balls are drawn in succession, each balls being replaced in the box before the next drawn is made. Find the probability distribution for the number green balls. So, let x is equals to 0, 1, 2, and 3. So, for the green balls, we have 2 over 6 is equals to 1/3. For black balls, we have 4 over 6 is equals to 2/3. So, therefore, we obtain the probability distribution using this probability distribution formula. P, x is equals to x is equals to 1/3 raised to x, our green balls, times 2/3 our black balls raised to 3 minus x. So, as a result, P of x is equal, P, the quantity of x is equals to x, we obtain as a result of 2 raised to 3 minus x over 27. So, for the number 2 problem, so 3 cards are drawn in succession from a deck without replacement. Find the probability distribution for the number of spade. So, let x denote the number of spade cards in a drawn of 3 cards without replacement, so that x could take the value of 0, 1, 2, and 3. So, there are 13 spade cards in a deck of cards, and there are 39 cards which are not spades. So, solution, 0, 13, C sub 0 is equals to 39, C sub 3 all over 50 over 52, C3 is equals to 0.4135. So, for the 13, C sub 1 times 3a, C sub 2 over 50 divided by 52, C3 is equals to 0.4359. So, for number 2, 13 sub C sub 2 is equals times 3a, C sub 1 divided by 52, C sub 3 is equals to 0.1376. So, 13, why 13? Because the 13 spade card. So, C sub 3 times 3a, C sub 0 divided by 52, C sub 3 is equals to 0.0129. So, for the table, so number of spades drawn is equals to 0. Wow, we have 0, 1, 2, 3. So, probability of 0 is 0.4135, for 1, 0.4359, for 2, 0.1376, for 3, 0.0129. Next, for number 3, from a box containing 4 10 peso coins and 2 5 peso coins, 3 coins are selected at random without replacement. So, determine the commutative distribution function of the random variable representing the number of 10 peso coin. So, given, we have the number of 10 peso coins, we have 4. Number of 5 peso coin, we have 2. Total number of coins, we have 6. So, our t is a random variable. So, P, the quantity of t is equals to 30, is equals to 4 C3 times C times 3, C sub 0 is all over C sub 6, C sub 3 is equals to 4 over 20. So, for P, the quantity of t is equals to 20 is equals to 4 c sub 2 times 3 c sub 1 all over 6 c sub 3 is equals to 4 over 20. So for P, the quantity of T is equals to 25 is equals to 4 c sub 2 times 3 c sub 2 all over c 6 c sub 3 is equals to 12 over 20. So applying the formula ET is equals to summation of T times PT. So the quantity of 30 times 4 over 20 plus 20 times 40 over 20, we got the final answer of 25. So for 10 peso coin, we have 3, 1, 2. For 5 peso coin, we have 0, 2, and 1. For the total, we have 30, 20, and 25. So next for the number 4, an insurance company sets its annual premium on its life insurance policy so that it makes an expected profit of 1% of the amount it would have to pay out upon death. Find the annual premium on a 200,000 Philippine peso life insurance policy for an individual who will die during the year with probability of 0.02. So let B as a death, let B death is equals to 0.02. So for P sub X is equals to our profit. So 0.01 times 200.000. So our X, the quantity of 1 minus 0.02 RP plus the quantity of X minus 200.00 times 0.02. So 2000 is equals to 49 over 50 times 0.02 RP times negative 4,000. So Rx is equals to 600, which is our final premium. So for the number 5 problem, according to a study, there is a roughly an 80% chance that a person of age 20 years will be alive at 65 years. So suppose that 3 people of age 20 years are selected at random. Determine the probability distribution of the number of alive at age 65. Also, find probability that the number alive at age 65 will be at exact 2, for B at most 1, C at least 1 rather. So for this problem, let P sub X is equals to 0 is equals to 3, 0 times 0.8 raised to 0. The quantity of 1 minus 0.8 raised to 3 minus 0. We got the answer of 1 all over 125. For P, X is equals to 1. 3, 1 times 0.8 raised to 1. The quantity of 1 minus 0.8 raised to 3 minus 1. We got the answer of 12 over 125. For P, X is equals to 2. 3, 2 times 0.8 raised to 2. The quantity of 1 minus 0.8, 3 minus 2. We got answer of 48 over 125. So for P, X is equals to 3. We have 3, 3. 0.8 raised to 3. The quantity of 1 minus 0.8, 3 minus 3, we got 64 all over 125. For P, the quantity of x or less than or equal to 1 is equals to P times x, the quantity of x equals to 0 plus P sub P, the quantity of x is equals to 1, we have 13 over 125. For P sub the quantity of x or greater than or equal to 1 is equals to P x is equals to 1 plus P, the quantity of x is equals to 2 plus P, the quantity of x is equals to 3. We got 124 over 125. So, identify the 5 uses of Poisson distribution. First, in biology, to count the number of the bacteria. So, second, the count of the number of typing error page in a type. So, third, to count the number of death at a particular causes. For the number 4, insurance problem to count the number of casualties. And last, to count the incoming calls in a town. And last, for the number 7, the second leading genetic cause of mental retardation in Fragile X syndromes, name of the fragile appearance of the tip of the X chromosome in affected individuals. 1 in 1,500 males are affected worldwide, with no ethnic bias. So, A, in a sample of 10,000 males, how many would you expect to have Fragile X syndromes? So, lambda is equals to nano, so RNP 10,000 times 0.00067 is equals to 6.667. So given pala tayo ng N greater than or equal to 100, RNP less than or equal to 10, NP is equals to 10,000 or greater than or equal to 100. So P is equals to 1 over 1,500 is equals to 0.0067. So applying to formula of lambda, kaya yun, nakuha natin yung 6.667 RP. Thus, the expected number of males have a Fragile X syndromes is 6.667. So, for B, for a sample of 10,000 males, use the Poisson approximation to the binomial distribution, determine the probability that more than 7 of the males have Fragile X syndrome. So, using probability distribution formula, P, the quantity of X is equals to X is equals to P, the quantity of E raised to negative 2 lambda squared all over X factorial. So, P, X greater than 7 is equals to 1 minus P times X is equals to 0 plus P X is equals to 1 up to P X is equals to 7. So 1, the quantity of negative P, E raised to negative 667 times 6.67 all over 0 factorial plus P, E raised to negative 667 times 6.667 raised to negative 1 all over 1 factorial. So, up to E raised to negative 667 times 6.67 raised to 7 all over 7 factorial. So, we got is equals to 1 minus 0.6477. We got the final answer of 0.3523. So for letter C, for a sample of 10,000 males used to the Poisson approximation to the binomial distribution to determine the probability that at most 10 of the males have Fragile X syndrome. So P, the quantity of X is equals to X, is equals to P E raised to lambda, the quantity of lambda raised to X over X factorial. So P, the quantity of X less than or equal to 10 is equals to P times X is equals to 0 plus P X is equals to 1 plus up to P X is equals to 9 plus P X is equals to 10. So applying P, the quantity of E raised to negative 667, the quantity of 6.67 raised to 0 over 0 factorial plus P, the quantity of E raised to negative 667, the quantity of 6.67 rather raised to negative 1 over 1 factorial up to P E raised to negative 667 times 6.67 raised to 10 all over 10 factorial. With that, we got a final answer of 0.9231.